So the next thing I want to do is to introduce some of the basics of CatBot and all the things that you're going to have to put into your Catia model to make it work. And each release of CatBot will come with an instruction set that will include in the workflow folder. And if you open this up, it's basically a text file that shows you step by step on how to change your model and what to add to it to make it work. So it starts with these world parameters, and these will have to be included, each one of these, in your parameter, in your tree under your parameters in each model. And these basically provide the global parameters that tell Robot how to apply the loads and what kind of loads to apply to your model. So in here it has things like wind load, which will be global, live loads, and it also will have specifications for your structural members. With CatBot, we'll mostly be using tube members, or like steel tubes, and you have the option of using up to 3 different size tubes, and those sizes, the diameter and the thickness, are specified here. You're also able to specify the direction of the wind and also the building load, which if you're testing just a small segment of a building, you're able to compensate for all the building above that segment with this value. Next, you get kind of an overview of the structure that you're going to have to put into your Catia model. And this gets very specific in terms of organization of your geometry and also the naming in order for CatBot to be able to read it. So what CatBot will do is it'll go into your Catia file and search through your geometric sets to find the geometry that you want it to convert into a robot model and then test. So all geometry that will go into a robot has to be organized in this folder structure. So every geometric set you have in your model will have to contain these sub-geometric sets. And the first one is an analytical set, so a geometric set actually called analytical set, and then 3 sub-geometric sets within the analytical set, one called points, lines, and plates. And this is all the geometry that you will be able to use. Each point will be converted into a node in Robot. So in the points geometric set, you'll put point objects and you'll specify whether they're fixed or free. Fixed basically means a bearing condition. So typically this is the bottom of your building, somewhere where it will bear into either the earth or a foundation. And then all the other points become free and they're able to have reactions put on them. In lines, you'll have most of your structural elements, and like I said before, these are mostly tubes. And then plates are made with polyline objects in Catia, and they include a shear plate, which can be used as a structural member for things like cores. If you're dealing with concrete kind of load-bearing wall conditions, you'll use those. And then you also have 5 types of plates which correlate to specific loading conditions in Robot, and this is how Robot applies things like wind load and live loads to your model. So here you have panels that represent wind load and slabs that represent live load and some combinations of those. And these sometimes, most often, don't correlate to specific design elements in your model, but they're things that you'll put in just to provide the right load conditions in your model. And the next section basically shows some of the syntax of the CatBot kind of batch file and things that you need to run CatBot and how to output your files. And we'll use this when we start to set up the workflow in modeFrontier. Okay, so the first thing we want to do with our model is to actually create those series of parameters that we saw in this text file. And to do that, it's usually best to just open up another version of this file. Here I have, we'll be distributing an example file, and you can just copy and paste those parameters from that file. So in this model, I happen to have all of these already set up, so I'll simply copy and paste those into my main parameter folder in my tree. And we'll be distributing this example file that's generated from this tutorial, and you can copy and paste those from there. And for the most part, you can keep the default for now, but all of these things are things that you'll be able to change that are specific to your design and also to calibrate your experiment. So the next thing to do is to start to organize the geometry of the model and rename things and get it ready for processing by CatBot. And I've created the structural geometry in two different ways in this model, just to show you two different ways you will be renaming and organizing your geometry. If we turn all the generative geometry off, you'll see that I created this core manually in these geometric sets. And what I want to do is make sure that CatBot knows to look at this geometry and transfer it to the robot model, as opposed to this geometry, like the perimeters, that I'm using more just to develop the model, and I don't want it to actually be transferred into structural components. So if you look at how I made this, there's a series of points that will have to be transferred in as nodes, and then there's also a series of these plates that I made as polylines, and I want those to become shear plates in